Today we're going to look at integrals of inverse trig. Okay, let's first remember the derivatives, and I've got them written up here. All right, so review over them, look over them. We don't use these a lot. Some of the ones that pop up the most are the arcsine and arctan. All right. And say if we want to integrate, okay, u is a differentiable function of x. So say if we had x here, okay, and it'd be x squared, we would take the derivative of x and it would just be 1. So we would have 1 here, okay, and we have the square root of 1 minus x squared. Okay, so therefore this would be, when we integrate it, would be arcsine x plus c, okay, because we see that this is the derivative. Same thing for cosine. All right, notice it's negative 1 over square root of 1 minus x squared dx arc cosine x plus c, or if you actually take the negative and put it to the outside, it could be negative arc sine x plus c. So therefore, we can actually simplify, and we use arcsine for antiderivatives. Instead of using the arcsine or the integrating something like that, we really just need to memorize these right here. The ones that are most used are the top two with arcsine and arctan. Make sure you write them down and make sure you have them memorized. We're going to be dealing with ones that not only do we have x, but we're going to have a is going to be something else other than 1 as well. All right, so we will have to use some u substitution in here. All right, so keep these handy, have them memorized. All right, so here we go. When I started looking at this one, I think, okay, sine. Well, here, make sure you identify what your a is. Okay, a here would be, and think not 4, it's the square root. Okay, so that's going to be 2. All right, and then u is x. Well, remember we have to do du dx, take the derivative of it. All right, so this is going to be arcsine. And we can say arcsine of, and since I didn't need anything extra, I can just do it straight without plugging in any u's or anything. It's going to be, it's u over a. So u is x over a, which is 2, and then plus c. So that one's pretty straightforward right there. Now let's go look at this next one. Now this next one is tangent. All right, it doesn't have any of the square roots in it. Okay, so it's not secant or sine. All right, so here in this case, now remember that this is a squared plus u squared. Okay, well here think u squared would be 9x squared. Take the square root. So u is actually 3x. All right, here a squared equals 2, so a actually equals the square root of 2. Keep that in mind. Well, here when I take the derivative, it's du equals 3 dx. I don't have the 3 on there. All right, so I'm going to move this over. So I'm going to need the 1/3. All right. So 1/3. And if you want to, what we can do is just go ahead and change this. So it looks like that right there. All right, so now 1/3 arctan. All right, and one of the things I forgot is with arctan, it's 1 over a. A is the square root of 2. Okay, arctan of, it's supposed to be u over a. Well, remember u is 3x over a square root of 2. If I want to clean this up, it's 1 over 3 square root of 2 arctan of 3x over the square root of 2 plus c. All right, let's look at this next one. Start analyzing it for a second. And when I first look at it, I think, it looks like sine. All right, but my problem is I got that x plus 2 up top. Well, what I can do is actually split this. Oops. And that's a minus. Now, the difference between this is I can really just use u substitution on this first one, because if I think about it, if I make u 4x minus x squared and I take the derivative of it, well, guess what? I have that x up top. So if you ever have the x up top, see if you can just do u substitution right there. I'm just missing the negative 2, so negative 1/2 du equals x dx. All right, so really when I'm integrating this is going to be negative 1/2. All right, really this is u to the negative 1/2. Don't forget that's a square root. All right, du. And I'll deal with that in just a second. Now, let's look at this one right here. Now here, the problem is I don't have my x. All right, here think a squared is 4, so a equals 2. Here, u squared equals x squared, so that means u equals x. Well, what's the derivative? dx. Well, I've got this extra 2 in there. All right, now this one, I'm going to go ahead and integrate this one from the beginning. So I've got this extra 2, and this is sine, so I'm going to say arc sine, and it's u over x. I mean, u over a, sorry. So it's x over 2. Now I just have to integrate this part right here. All right, for this part, it's negative 1/2. I add 1, so that's going to be positive 1/2, and divide by 1/2. All right, and every time, guys, I know this seems redundant and seems like a lot of work, but always rewrite this out because you always want this equivalent to that, and you want your math to be correct. Now the 2's cancel here, and I'm going to go ahead and plug in for this u. Now this u dealt with this right here. Okay, and there's going to be a negative on the outside, so negative 4 minus x squared to the 1/2. If you want to put square root, you're welcome to. And then I'm going to rewrite the rest. All right, so it is kind of a long answer right here, and just be careful. So you got to treat these two integrals different from one another. All right, moving right along. Let's look at number 4. Now, when I started to look at this, I'm like, wait a minute. If you recall the first thing I did at the beginning, which one does it actually look like? It actually looks like arc secant. All right, and the reason is because I got this x outside of here. But my problem is this. My u squared is 4x squared. So when I take the square root, u equals 2x. All right, my a squared would be 9, so a equals 3. My problem is this. This is supposed to be u out here. All right, but it's not. Well, how can I get it to be there? Well, if you ever just multiply by 1, you can get it to be there. All right, and do something like that. So this just equals 1 here, but now I got that full u. All right, I just have this extra 2 at top, so when I do it, it's going to be 2. All right, remember arc secant's just like arc tan, and you got 1 over a, okay? And then it's arc secant, and it's the absolute value of u, so absolute value of 2x over a, which is 3. All right, so when I clean it up, it's 2/3 arc secant, absolute value of 2x over 3 plus c. All right. However, I did forget something. Go back here because actually this 2 doesn't belong, and let me show you why. I forgot to do this right here. I have the 2 here. All right, so this is that du right there. So really, I don't need the 2. Sorry about that, and sorry about forgetting that right there. So really, this is my final answer. All right, moving on to number 5. Sorry, I do make mistakes. All right, now on this one, when I start looking at this, it's like e to the 2x minus 1. It's got the square root. The problem is this right here. Okay, when I go and do arc sine, it's a squared minus u squared. U is the one with the x. The u squared minus a squared. Well, if you notice, the u squared comes first, so it's really looking like secant. The problem is I don't have e to the x right here, or I don't have like the u. Okay, well, let's think about this for a second. If I make, all right, u squared is e to the 2x. When I take the square root, u is going to be e to the x. All right, I'll have to take the derivative in a second. I won't forget it this time. Okay, here a squared equals 1, so a equals 1. Well, I need this u on the outside. Well, let's think about this for a second. I can actually put e to the x over e to the x dx. And this one's going to work out nicely. All right, and the reason why this is going to work out nicely is because when I take the derivative of e to the x, isn't e to the x? And so look, that's that whole thing up there. So now this is the u, this is the u squared, and this is the a squared. So now I have the arc secant. But remember, it's 1 over a, my a value is 1. Arc secant is the absolute value of u over a. All right, so just to clean it up, arc secant. And really, I don't need, if you think about it, e to the x doesn't ever go negative, so really you could just have e to the x like that without the absolute value. All right, so with or without is fine. Now, let's compare some of these and what they kind of look like. When I start to look at, say, this one right here, okay, the u squared comes first minus the a squared, and I have the u outside. Okay, so this one's actually arc secant. All right, if you want to actually do this out, let's see, u squared equals x squared, so u equals x, du equals dx, so I've got the dx there. All right, a squared equals 1, so a equals 1. All right, notice I got the u out there. So this is just, again, it's 1 over a. Okay, well, 1 over 1 is just 1. Arc secant. The absolute value of x over 1. So just arc secant, absolute value of x plus c. And you do have to have the absolute value here. Now, when I start looking at this one, I think, it's arc sine. However, I got this x up top. If I ever have the x up top, I probably most likely am going to use u substitution, because look right here, when I take the derivative of this, I have that x, and there's the x. I'm just missing the 2, so I need the 1/2. So here this would be 1/2, and really this would be u to the negative 1/2. So when I go and do it, it's going to be 1/2 u to the 1/2 divided by 1/2. All right, the 2's cancel, and I can replace the u. So really this is just square root of x squared minus 1 plus c. And then this one, when I look at it, it's like, oh, x squared minus 1. It looks like sine, but let's go back to this again. I can't have the x squared out front. It's got to be the a squared. So really, this one, and since it doesn't have the x up top, I can't use u substitution. This one, it cannot be evaluated. All right, so be careful, especially with secant and sine. If you have the x squared or the whatever's with x first, then that's going to be secant, okay, and not sine. All right. Moving right along, let's look at number 6. Okay, sometimes we do have to do tricks. We're like, okay, I don't know what to do. I can't make this u because I need a 2x minus 4 up top, and I don't have it. But some of the things we can do is complete the square. Okay, so if I go and I do, okay, x squared minus 4x plus something, all right, I have the plus 7, and whatever I add here, I need to subtract. Okay, remember completing the square, take half of that, that's negative 2. Negative 2 squared is 4. So if I add 4 here, I need to subtract it. So this is going to be x, when I factor it, minus 2 squared plus 3. All right, so this is actually looking like arctangent. So when I recall arctangent, here we go, it's a squared plus u squared. Okay, well here a squared is the x minus 2 squared, so that means a equals x minus 2. All right, my u squared is, and I should have done, this is actually my u squared. All right, a is actually the 3, so a equals square root of 3. All right, it is okay to have u squared here and then a squared, or you can have a squared u squared because it's addition. Now, I do need to take the derivative. Okay, I don't need anything extra. I just have the dx, which is good. So this is just arctangent. So it's 1 over, all right, it's 1 over a, so it's square root of 3, arctan. All right, and then it's u over a. So my u is x minus 2 over a, which is square root of 3. I'm just going to put parentheses around that. And there's our final answer. Again, don't box answers. We've talked about this before. Please don't box them because in a short answer, if you do something wrong, they'll count it wrong if you said that was your final answer. All right. And number 7, what if I wanted to find the area bounded by the graph of f of x, so this graph right here, and the lines x equals 3/2 and x equals 9/4. All right, so really I'm integrating from 3/2 to 9/4. Of 1 over the square root of 3x minus x squared. Now the problem is I have x right here. I can't just say this is my a squared. Okay, and I can't just say x squared is my u squared. I do need to complete the square on this one. Now, what I'm going to do is negative x squared plus 3x. All right, that's what I've got. I've got to take out a negative. I'm going to add something here, but then I subtract it out here. Now, what's actually going to happen is when I take half of this and then I square it, it's 9/4. But I have this negative on the outside. So really, it's like I'm adding negative 9/4. Well, I need to subtract negative 9/4, which makes positive. When I go to factor this right here, it becomes x minus 3/2 squared plus 9/4. So when I meant to put a dx right there. It's 1 over the square root. All right, I'm going to flip-flop these two and put the 9/4 first, minus x minus 3/2 squared. All right, so let's start looking at this. This is your a squared minus u squared. So this is looking like sine. So here, a squared is 9/4, so a equals 3/2. My u squared is the x minus 3/2 squared. So my u equals x minus 3/2 if I took the square root. And then remember, we got to continue and do the derivative. I don't need anything extra. So this is straight up sine. Arc sine. I don't remember, arc sine is the one that does not have the 1 over a. Okay, this is u. All right, this is x minus 3/2 over a. Now, I'm going to tell you, if it was multiple choice, you can't leave it like that. Otherwise, you honestly could. So you need to come and just kind of simplify that. really what's happening is you're taking this x minus 3 halves. If you're dividing by 3 halves, you're multiplying by 2/3. All right, and what actually is happening is when I distribute is 2/3 x minus 1. So if you really want to rewrite it, it's arc sine of 2/3 x minus 1 plus c. All right, and actually I shouldn't have put the plus c. What should I have put? All right, remember you're doing this from 3 halves to 9/4. All right, so when I plug in, and I am running out of room, so what I'm going to do is I'm going to erase some of this right here so I have enough room to finish the problem. If you need to go back and look at it on the video. Okay, so here, arc sine of, if I put 9/4 into here, okay, think 2/3 times 9/4. That makes 3 halves. Okay, and 3 halves minus 1 is 1/2. So arc sine of 1/2. I kind of did some of the math in my head. All right, and then when I plug in 3 halves, so it's minus arc sine. When I plug in 3 halves, well, 2/3 times 3 halves is 1. 1 minus 1 is 0. All right, remember arc sine. You got to think, okay, when is sine 1/2? Sine is 1/2 at pi over 6. Here, when is sine 0? Sine is 0 at 0. So this ultimately equals pi over 6. This is a little tricky. This is a little bit harder than the last things that we have done, and it's harder to see. Sometimes you will need to use completing the square. It does make it a little more complicated, especially if you have fractions like this one did, but you need to make sure you stick with it and make sure you have these memorized right there.